and section 2.1 on frequency distributions. So for this first example, people were asked, what age was your mom when she had her first child? And then the information is in this table, which is called a frequency distribution. So the ages are 14 to 18. 6 people said that's when they had their first child, etc. So these are the ages going up this side. And then the oldest were from 34 to 38 when they had their first child, and 2 women said that. Now find the relative frequency. So the relative frequency basically means this was 2 out of how many people total. So first of all, the total number of people, when you add those up, this is going to be 2 plus 3 is 5. Another 5 makes 10. Add that to this and that's 22. 6 more is 28. So that's called the sample size. N is equal to 28. And then over here in this column, what I'll do is divide 2 divided by 28, 3 divided by 28, etc. So I've got the 2 divided by 28, the 3 divided by 28. So there they are as fractions. And then you could just put that in a calculator and find the decimals. Now on the My Stat Lab homework, they may ask for the decimals. So here we go with the decimals, or they may ask for the percent. So for percent, just multiply by 100. That will move the decimal to the right by 2, meaning that the first one is 7.1%, 10.7, 17.9, 42.9, and 21.4. So there's the relative frequencies, both as a decimal and then as a percent. Now that I've got this table here, there's some other definitions that I want to go over. One is the lower class limit. So let's say you go to this class right here, 24 to 28. So what's the very lowest or the very youngest you could be to be in this category? It's 24. This one's 19, this one's 14. So the lower class limits are basically just these numbers on the left. So the 14, 19, 24, 29, and 34. And I'm sure you guessed what's coming next, the upper class limits. So to be counted in this category right here, the very upper score, or the oldest age, would be 18. For this one, it's 23, 28, etc. All the way up to the 38. Okay, next up, the class boundaries. Hey, where'd you go? There it is, the class boundaries. So if you look at this class, it ends at 18, and then this one begins at 19. So the boundary between 18 and 19 would be 18.5. This one ends at 23, and this one starts at 24. So the boundary between those two, between 23 and 24, is 23.5. Now, you need to have a boundary on each side. So for example, this 14, since we're going by 0.5, just to the left of 14 would be the 13.5. Then here's the 18.5 that separates these two. The next one would be 23.5, separating these two. And then it's eventually going to be 33.5, and then you need to put an extra boundary on this one, 38.5. So those are the class boundaries. Next, the class width. Well, there's a couple of ways to do it. One is, if you look at this category right here, it includes 14-year-olds, 15, 16, 17, and 18-year-olds. So it includes 5 ages. Well, another way to do that is you could just take 2 of these lower class limits and subtract them. So 19 minus 14, it also gives you the 5. Or 29 minus 24, it also gives you the 5. Or you can even do it on this side. 28 minus 23, it also gives you the 5. So the width shows up over and over again on this side of the table right here. But the easiest is just subtract 2 consecutive lower class limits. That is the width. Now we're going to make a table on our own. So these aren't ages or anything, these are just numbers that I randomly made up. And then we're going to make a frequency table with 4 classes. The first thing to do is you find the range. So you look through the scores, and you find the biggest, which is 15. You find the smallest, which is 1, subtract those, and that's going to be 14. Now take this number 4, and we're going to divide. So whatever they say to use for the number of classes, that's what you divide by. So it's the range divided by the number of classes. It gives me a 3.5. But when I make this table, I don't feel like using a decimal. So I need to round up, and I'm going to round it up to 4. If this was a 3.1, I would still round up to 4. So this is not just the regular rounding rule, it's rounding up. No matter what the decimal is, round up to the next whole number. That's going to be my width. Now start making the table. So you start at the very bottom and you put the very smallest score, which is a 1. Then you take the width and you add it on. So 1 plus 4 will be a 5. That's the next lower class limit. Then you add on the 4 again, so the next one is going to be a 9. Then you add on 4 again, the next one will be 13. So those are all of the lower class limits. Now before I go to the next slide, check out this. So this one down here goes from 1 till what? Well, if this one starts at 5, this one's going to have to end at 4. And then this one used to have a blank here, but if this one is starting at 9, this one has to end at 12. Or you could also take the class width, which is 4, add on, you get 8, add on, you get 12, add on, you get 16. Now there's one small little adjustment that sometimes you have to make. Suppose that somebody came in and said, hey, I've got a 17, we need to include the 17. And you're like, oh, well, what do I do? Well, just for this 16, just erase it and put a 17. So it's just this last number right here that sometimes you might have one number that's a little bit bigger. Go ahead and just adjust that and make that go from 13 to 17 right here. Now the next thing is just count them. So you just count how many numbers are 1, 2, 3, or 4. Just go through the list and count them, and there's 9. How many numbers are 5, 6, 7, or 8? Count them. That's the frequency. So the frequency also means the count. When you count them, how many are there? All right, so that is the frequency distribution. Now when you take a look at the graph of the distributions, they could basically be like one of these 3 examples. So of course they could be completely random and a mess, but I mean, for those that fall under some pattern, there's these 3 main patterns. One is all of the classes are about the same, so that's called uniform. Another is you start off with a very small class, so there's not very many people here, then a few more, then a few more, then a few more, and in the middle, which is where the average would be, that's where the most people are. And then it would just taper back down. So that's called a normal distribution, which is normally what happens, so that's why it's called the normal distribution. And then this is called skewed. So this could be something like grades in a calculus class. So how many people got 100%? Well, there's a few, not a lot, but a medium amount. How many people got 95%? How many people got 90%? And then 80%, 70%, 60, 50, 40, 30, 20, and somebody got 10%. So that's called a skewed distribution. And it could be that the bigger lump is here on the left, or it could be the opposite. It starts off small first, and then the bigger lump is over on the right. Either way, it's called skewed. So here's a table that I just randomly made up. It wants to disappear. And then make the bar graph based on this. Okay. So here's how I do it. So for the category that goes from 60 to 64, I average those two, add them together and divide by 2. That would turn out to be 62. So there's a 62 right in the middle. So then I put a 62 down here on the x-axis. And that goes up to 10. So this would go up to 10. By the way, I don't know why that says inches. Just ignore that says inches. That's supposed to say frequency. The next one, the average of a 65 and a 69 is 67. That's right in the middle. So in the middle of the bar, you put a 67 and then have that go up to 22. So right here is 20. So it's just a little bit more. It's 22. And then you just continue. The middle right here would be 72. So that's the middle right here. And then have it go up to 74. So that would be 70. So approximately right there is 74. And then that is that's pretty much a normal distribution. All right, I hope to see you again soon.